Hello, 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 everybody. I hope you are all doing well, you're feeling fine, and you are ready for more of the open paper, the 2016 open paper to be exact. And we are on A4. So what have we got? Three males and two females write their names on sheets of paper and randomly arrange them in order from left to right. So we got a total of 5 sort of sheets of paper. What is the probability that all of the female names appear to the right of the male names? So we want a strict split, the two female names over here and the 3 male names over here. Okay, so it's a probability question, and how do we do probability? We count the number of things that we want, the number of scenarios or outcomes we're interested in. That is to say, the number of ways to get all the male names on this side, all the female names on this side, that sort of a thing. And we divide it by the total number of ways to arrange the names, the total number of possible outcomes, not just the ones that we want to count, the ones that we're interested in. So that's basic probability. I mean, it does get harder when you hit university if you take the right class, but that's the gist of it. That's the idea. So, okay, we've got 3 male names and 2 female names. And so we want a number of outcomes that are 3 male and then 2 female, and we want to divide by the total number of arrangements of the names. Okay, well, how many names are there? There's 5 names, and if we wanted to just imagine any way to write them down, well, how many possibilities are there for the leftmost paper? Well, there's 5. We're not counting the males or the females right now. There's 5 possible ways to get 5 possible names that could appear if we flipped over the leftmost paper. How about the next paper, the next leftmost, the second from the left? Well, there's already 1 name under here, so I guess that leaves only 4 possible names. Which names? We don't know, but there's 4 that are in the running once the leftmost is flipped over. And we keep going on like that until we get to the rightmost, in which case the other 4 pieces of paper may have already been flipped over or their names have already been assigned, and we're left with just one last person, and they have to go in that spot. So this gives us 5 times 4 times 3 times 2 times 1. This is also known as 5 factorial. 5 times 4 times 3 times 2 times 1. You might be familiar with this. I'll just write down factorial. It's useful for counting problems, especially more advanced counting problems. It's just the number of ways to arrange things, and it's got this nice little exclamation mark symbol. But either way, we can figure it out. It's 120. 120 is 5 times 4, which is 20, times 3, which is 60, times 2, 120. So that's going to be the bottom number here. Now let's go through the same reasoning, but talk about the specific case we want, where the female names are all over here and the male names are all over here. So how many choices for the leftmost piece of paper? Well, there's 3 men, and we want at least we want a male name here. So there's 3 possibilities. We don't want either of the 2 female names to appear. Similarly, once that piece of paper has been placed and it's a male name, we've got 2 male names left here and 1 male name left there. Same sort of work with the females. You could come in from the right-hand side if you wanted and say there's 2 possible female name choices for this piece of paper and 1 for this. And we just multiply everything together, so we'll get 6 times 2, which is 12. So the probability is going to be 12 out of the total 120 possible ways, or 1/10, or if you wanted to leave it as a decimal, 0.1. Okay, so 0.1, we'd fill that in as our probability. And there we go, and that wraps up part A. So up next, we're going to be taking a look at part B of the contest, so if you want to, feel free to join me for that. Thank you guys, as always, for watching, and I will see you for B1 in the next video. Take care.